This video is going to take you through your free response question from your Unit 2 exam. Now, there were multiple versions of the exam, but the overall questions were very similar. So this version might look a little different than yours, but hopefully you can make the connection with which one you had. So we were given the table of g, which is a differentiable function and therefore continuous. We have the function h right here, and then we have this function f of x. That's the equation. Part A said find the slope of the tangent line. Well, the slope of the tangent line is the same thing as finding f prime of x. Specifically at x equals pi, we would take the derivative and then substitute in pi. So f of x was equal to the sine of 2x. Some of you, I think, had the sine of 4x. But again, you'll see the similarities in a second. So f prime of x, we're going to take the derivative of sine, which is cosine, leave the inside alone, times the derivative of the inside. So there's a point there for the chain rule. Then the derivative of cosine is going to be negative sine of x. This is where then we wanted to rely on your unit circle knowledge. F prime of pi is going to be equal to the cosine of 2 pi times 2 minus the sine of pi. All right, so in cleaning up this answer, the cosine of 2 pi is 1 times 2 minus the sine of pi is 0. So we get that f prime of pi is equal to 2. Quick notes about that. I would make sure that you labeled your lines as f or f prime, depending on when you are writing. Some of you just left them unlabeled, I guess you could say. We call that a bald answer in mathematics. So just be careful in showing your work in those steps. All right, question B for some of you. Some of you, this might have been question C, but let k of x equal h of g of x, find the value of k prime of negative 3. Well, before we can find k prime of negative 3, we need to find k prime of x, which again is going to be the chain rule. So h prime of, leave the inside alone, times the derivative of the inside. This then is where a lot of people lost some points, because you got to be careful about what we're actually subbing in here. So g of, I'm going to leave these blanks, I'll fill them in with a different color here in just a second. We're looking for k prime of negative 3. So negative 3 goes in all of these spots. And what you want to do is you want to think back to your pre-calculus knowledge and work from the inside out. So you need to find g of negative 3. Well, g of negative 3 is 2. So this becomes h prime of 2. Okay, some of you just multiplied h prime times g of negative 3, but it's h prime of g of negative 3. So think about that composition piece. G prime then of negative 3 is 4. So the last thing I need in order to complete this is to find h prime of 2. Well, h prime represents the slope of h at 2. So I'm looking for the slope of this little blue line. Well, the slope of this entire line is down 1 over 3. So down 1 over 3 times 4 gives me a final answer. K prime of negative 3 is equal to negative 4/3. Okay, so again, some notes on that one. Make sure that you're doing h prime of g of negative 3, right? And then make sure you're counting your slopes correctly on that linear piece of your graph. Part C, is there a value of x for which g of x equals 4? How do you know? Justify your answer. So some of you had g of x equals 4. I think some of you had g of x equals 8. But the concept here is going to for sure be the IVT. So my answer would be yes, because g of x is differentiable it is continuous, and 4 is somewhere in between. And this is where you have some options. So some of you used the fact that 4 is just in between the full endpoints, which is great, right? So 0 is less than 4 is less than 10. Some of you focused in and said, well, 4 is actually between 5 and 2. So you would have put 2 is less than 4 is less than 5. That's also great. Either one works. Then, I don't know why I switched colors, but I did. Then, by the IVT, there exists x on, if you use the numbers in red, it would be x on the interval from -5 to 0, such that g of x is equal to 4. And so you can do from -5 to 0 because that's our full table, or you could have said from -4 to 3 because technically the 4 that we're going to cross through is going to happen somewhere in between x equals -4 and x equals -3. All right. A couple language things. So again, make sure you name g of x. Don't just say it. I know I say it here, but it's referencing that g of x. Make sure you clean up your language of the IVT. Some of you had the right kind of, I knew what you were saying, but just be careful in how you're saying it. And so this is like that Mad Libs fill in the blank that you can use. If you're going to use your own words, make sure that you're still setting up continuous and that your y value is between two endpoint y values. All right, D. This, I'm telling you, there is at least one x value where h prime does not exist. Name one of these x values and explain how you know the derivative does not exist. So the biggest thing I saw in here is that a lot of people named the value, but then said it doesn't exist because it's not differentiable. Well, that's like saying this shirt is blue because it's blue. Okay, so you got to think about what we're trying to say. So there were a couple of options. We could have said h prime of x does not exist at, and you only had to name one, right? Name one of these x values. Some of you listed x's and y's. We just need x values. H prime of x does not exist at x equals -3, -2, 0, or 3. So any one of those answers was correct. And we could say because h prime of x is not locally linear. And the reason it's not locally linear is because of the sharp turn. Even more so this would suffice, even more so, you could say that the slope from the left is not equal to the slope from the right. Right? We don't have a nice smooth curve. We have a sharp corner going on. Something I noted when I was going through and grading these is some of you said that it doesn't exist here because h prime is 0. H prime can be 0. That's a number. I mean, 0 has a lot of interesting features to it, but h prime being 0 exists. The slope is 0. You literally just said it. The slope is 0. So make sure we're careful about 0 slopes versus undefined slopes. All right, and then this last one, some of you had this one, some of you had the chain rule one from before, but it doesn't hurt to go over this, even if you didn't have this question. Let m of x equal g of -2x times h of x, find m prime of 2. So this one, again, we're going to need a product rule overall. Before I can find m prime of 2, I'm going to just find m prime of x, and that'll be the first times the derivative of the second plus the second times, you needed a chain rule in yours. So see how we were trying to get to the chain rule in both of these questions? G prime, leave the inside alone, times the derivative of the inside. So the next thing then is to go through and sub in 2 everywhere that we see an x. So I'm going to have m prime of 2, I'll come back to that in just a second, g of h prime of plus h of times g prime of times -2. And all of these are going to be 2's. So -2 times 2 is -4. H prime of 2, h of 2, g prime of -4, and then we still have this -2 over here. G of -4 is equal to 5. H prime of 2, we already had you find it. And another one, h prime of 2 is -1/3 plus h of 2. Well, let's think about this. If this is a slope of -1/3, then this has got to be -2/3. G prime of -4 was equal to -1, and then we still had this -2 that was hanging out from our chain rule before. So in cleaning up our answer, remember we're not going to be scared of fractions. We get -5/3 This negative negative makes a positive, but we still have a negative overall. So minus 4/3, which really ends up being negative 9/3, which is nice and simplified to negative 3. Okay, so there's your free response one. Of course, some of your free response questions look different, but hopefully I answered enough of each type of question that you feel confident in your answers. If you still have any questions, come see me during PLT on Wednesday, and we can definitely go over any specifics from your free response question.